Here's a different sort of problem that involves a rain trough. A rain trough is constructed from a piece of aluminum which is 20 inches wide and 50 feet long. Each edge is bent at a right angle to form the trough. How many inches should the edges be turned up to maximize the cross-sectional area and thereby allow the most water to flow through the trough? See the diagram. Well, we're going to make a diagram here. We start out with a trough 20 inches wide. Now the 50 feet long does not enter into the problem because all that we're concerned with is maximizing the cross-sectional area. Now we're going to bend the trough on the edges a certain amount to make a cross-sectional area of a rectangle. Now the amount we bend it up is something we don't know. So let's call it x inches. And it's going to be x inches on either side. Now if we started with 20 and we bend up each side x inches, how much do we have left over for the base? Well, since we bent this side up x inches and this side up x inches, the remainder is going to be 20 minus 2x. And the cross-sectional area will be the area inside here. So what we wish to do is maximize that area. Well, how do you maximize the area? What is the area? It's a rectangle, and the area of a rectangle is 20 minus 2x multiplied by x. So if you multiply that together, you get 20x minus 2x squared. Let's rewrite it as negative 2x squared plus 20x. Again, it's a quadratic function, and it opens down because negative 2 is a, and we can use the formula negative b divided by 2a to find the vertex. So negative 20 divided by 2a is negative 4. The answer is 5. So we should bend this aluminum piece 5 inches on each side, and the area is going to be, if we bend it up 5 inches, it's going to be 5 inches wide by 20 minus 2 times 5 inches long, and so it's going to be 5 by what? 10, and that's going to be 50 square inches, and that'll be the maximum area that we can get from that 20-inch piece of aluminum. Now the next problem involves a fencing problem, and we're fencing an area that's going to be a rectangular field. One side of the field lies along a river, so you don't need any fence along that side. And the other two sides are going to be smaller rectangular areas. So let's draw a picture. So here's the river. And then we're going to have a rectangular field with fences on the other three sides. And the rectangular area is to be subdivided into two smaller rectangular areas using fencing parallel to the river. Well, the river is here. Parallel would be a fence going this way. So here's what we got. We got fencing that's going to be required here and in the middle. Now let x be the length of the fence parallel to the river. So that means this is going to be x and this is going to be x. And the fencing that's going to be perpendicular to the river is going to be y. I'm going to just call it y. We can call it any letter we want. We're just using y. Now what's true about x and y? Well, we got 4,000 meters of fencing. So that means that we have 2 x's plus 2 y's. It's going to be 4,000 meters. That means if we divide by 2, x plus y is equal to 2,000. Now the total area of the field we need to express as a function of x. What is the area of the field? If we neglect the thickness of the fence, the area of the field is simply the area of a rectangle, and the product of x times y gives me the area. But this is not a function of x, it's a function of x and y. So what we need to do is we need to come down here and solve for y in terms of x. Y is going to be 2,000 minus what x is. Now we're going to take area and get x times 2,000 minus x. And now we have the area of the rectangle. Let's go ahead and multiply this out. 2,000x minus x squared. Rearrange. We see once again we have an inverted quadratic function that opens down, and therefore the vertex will be a maximum. How do you find the vertex? Negative b divided by 2a. Now the b value is 2,000, so it's negative 2,000 divided by 2a, negative 2. And so that's going to be 1,000. Once we find out what 1,000 is, we can find the area of 1,000. Instead of plugging it into this formula, we can substitute it into the formula above, and so the area of 1,000 is going to be 1,000 times 2,000 minus 1,000, and that's 1,000. 1,000 times 1,000 is 1,000,000. So we can enclose 1,000,000 square meters by this fence.